here we go. So finding antiderivatives. So f of x. So I'm going to carry the 2 and add 1 to the exponent and put it over 2. So this here, I'm going to carry the 2, and you recognize that as arctangent. And then you have to think of this as 1/3 times 1 over x, because the antiderivative of 1 over x is ln of x plus c. So these 2's cancel, so I'm going to use this information to solve for c. So 1/2 equals, so negative 1 squared is 1, minus 2 times the arctangent of negative 1. And you know, let me just write it down, ln of the absolute value of negative 1. Okay, be good thing we have the absolute value there, because this is 0, right? And so now I need to figure out what this is. So you know that the arctangent of negative 1 is the angle that if I take the tangent of it, I get negative 1. And remember, it has to be in that restricted region, so it's the angle negative pi over 4. So if I subtract this over here, so I get a negative 1/2 equals a negative 2 times a negative pi over 4 plus a c. So negative 1/2, so this turns into a positive pi over 2. Subtract it over, that's what c is equal to. So let me make some room here. So the final answer is f of x equals x squared minus 2 arctangent of x plus 1/3 ln of the absolute value of x minus 1/2 minus pi over 2, because that's all my big C. All right, so now let's do this one. So you're going to have this is a section 4 problem. So if it's thrown up into the air, that's the initial velocity of 64 from a height of 5. So that's the initial position of 5. So you always start with gravity, and since I'm in feet, that's negative 32. Then I'm going to take the antiderivative and put in the plus 64 for the initial velocity. And then s of t is negative 16t squared plus 64t plus the 5. Okay, so what are they asking me? They're asking me the maximum height. Okay, so first you have to find the time it reaches the maximum height, and that's when the velocity equals 0. So I set negative 32t plus 64 equal to 0, and that gives me t equal 2. And so what do I do with that? I put that into the position function. Hold on a second. Yeah, position function. And so s of, let me make some room here. So then I find s of 2. So, s of 2. S of 2 is going to be negative 16 times 4 plus 64 times 2 plus a 5. And I think all of that gave us equals 69. Okay, so now this next one has it being thrown down. So if it's being thrown down, that means your initial velocity is negative 5. It's in meters, so your acceleration of gravity is negative 9.8. So velocity is negative 9.8 t minus a 5. And then s of t is negative 4.9 t squared minus 5t plus, how high the cliff is. And that's what this is. So I need to find out what that is. So how do I find that? What do they tell me? They tell me it hits the ground in 3 seconds. So that means s of 3 equals 0. So if I put the time 3 into my position function, negative 4.9 times 9, right, minus 5 times 3 plus s naught, set that equal to 0, and solve for that s sub 0, I get 59.1.